Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this specific video, we're going to look at the concept of differentiation of trigonometric functions. And this of course is going to complement on the various discussions we have had on other the derivatives of trigonometric functions and their various inverses. So in this case, we're going to have a theorem whereby this one is the d over dx of the cosine of x given as negative the sine of x given as such. So therefore our work is going to basically try to confirm whether this specific theorem is just as it is given. And so therefore we're going to use various representation of the finding the derivative from previous discussion and see whether that basically is the case. So therefore I'm going to have this one represented in this specific form. So in our last discussion, I mentioned that basically if we have a function y f of x given as such, we can find its derivative, which is f prime of x as f into x plus h, where h is a small increment or a small difference in x. And as we said, this one is going to be the case as the limit of h tends to 0 given as such. So therefore, we're going to use analogous strategy of using this specific set of derivative in order for us to confirm whether this is true. So we have d over dx of the cosine over x, and therefore I'm going to rewrite this specifically, negative sine over x in terms of this difference quotient, which I've put on my right side. So this is going to be given in terms of 1 over h, and then I'm going to have the first set given us. So basically, whenever we are having these specific angles for the cosine, we can write this one in terms of the cosine over x plus h. So basically, perhaps I can just move this one first. So we're going to have this one written in form of the cosine over x plus h minus the cosine over x all over h. So I've done a substitution for this specific, just similarly with this specific general representation for the derivative. And this is going to be given in terms of a common factor given as 1 over h. And then we are going to have this one. So whenever we have this one, I've talked about the concept of the sum and difference of this specific trigonometric ratios, whereby the cosine over x plus h can be written in terms of the cosine over x, and then we have the cosine of h, and then that one minus the sine over x, and then the sine of h given and that. So this of course is the rules from the sum and the difference of angles, as we had done in our first discussion on the difference and the sum rule for discussion of these trigonometric ratios. Now in this case, I said that h basically can represent a small change or the phase change of this specific function. So therefore we're going to have the rule of this one and then minus this particular function of the cosine of x given as such, and the rule of this is going to be similar, or rather the same part of this particular function. Therefore, if you look at this specific case, we can do a rearrangement of the whole of this particular section, whereby we are going to have this cosine over x by cosine h minus the sine over x, the sine over h, and then minus the cosine over x, written as the common denominator over h given as such, this one that we have given as a common factor. So we can do a rearrangement in order to find the common factors, or the common like terms, as we can say as we can say in a general term. We can use this specific concept of like terms in order to simplify this, and therefore this is going to give us negative the sine over x, the sine over h, which is the second term, and then I'm going to have this one plus the cosine over x cos h over h, minus the cosine over x over h given as such. So this specific section, still I can do a simplification by perhaps introducing the brackets. So I'm going to have the negative, hope is going to be enough, negative the sine of x as sine over h all over h, and then plus, so I'm going to have the common factor of the cosine over x over h, which is a cosine over x over h into, so this is going to be cos h minus 1. So this is going to be cos h minus 1 given as such. So this minus 1 basically implies that I've taken out this specific section of cos x over h outside the brackets. And this basically, I can introduce what we call the, I can still change the sign, so I'll do a slight modification of this specific equation, whereby I'm going to have the sine over x. So this is going to be the sine over x sine h all over h. And this second part of the equation, I can do a slight modification by introducing a negative sign here for the cosine over x over h. And anything in the brackets as well, they are going to change the signs. So I'm going to have this one given as 1 minus the cosine of h given as such. So I've changed this cosine of x, it's a negative, and the negative one in this specific case is going to be a positive. Therefore, it's going to appear in this specific form. So this second part of the equation still can be written in terms of cos x into 1 minus cos h over h. Now we have said that we're going to have this limit as h tends to 0 given as such. So in this specific case, then therefore if we look at this specific section for the first one, I'd say that we can have the sine over pi over h over 2 over pi over 2 implying 1. So therefore, if you look at this specific section for the first one, we're going to have the sine over h over h. Therefore, this can be given in terms of a negative x times 1 as h tends to 0. This specific part of the fraction, which is the sine over h over h, is going to reduce to 1, and then minus. So for the cosine over h, as h tends to 0, the cosine of 0 basically implies 1. So therefore 1 minus 1 is equivalent to 0, implying that this second section we're going to have it given as the cosine over x equal to 0. So the second part of this specific equation is going to reduce to 0, implying that my basically my the value for the right side of this specific equation, we're going to have it given in terms of a negative the sine of x given as such. So basically from starting equation which we are given in this specific format, therefore this specific evaluation is going to give us negative the sine of x, implying that basically the derivative d over dx of the cosine over x is equivalent to negative the sine of x given as such. So basically that is going to be given as such. And I'm going to put a link of this specific or other similar videos concerning the product reciprocal rule, and perhaps the and together they are going to assist us find different ways of evaluating problem sets in case we come across them. So that is it for now, guys. Bye, God bless you. Catch us in our next video.